Let's take a break from databases and complicated node-nested functions. In this lesson, I show you a little about a basic HTTP security constraint that most web applications need to implement. The Cross-Origin Resource Sharing, or CORS, is a mechanism that allows applications to access resources in another application. For example, storing images in one site and using it in another. This is particularly important for web browsers. If a web page tries to access information using a RESTful web service, but that service is in another server different from where the page is hosted, then the cross-origin protection will try to be enforced. How does it work? Your service provides a list of allowed methods and servers that can access the service. Then the browser checks if the page that is trying to access the service is in that list and allows or denies access based on that check. Why do you want it? Your service can be hosted on the cloud or on your machine. And right now there is no client for the application. You have tested using a REST client, and REST clients do not enforce cross-origin policies, but web browsers do. If you want to use your service from a web application, then you will have two options. Either host the web pages as a part of your service or host the web pages as a separate application somewhere else. If you bundle the web pages in your app, you don't need cross-origin support. But this will also limit the usage of your application by external applications. Also, if you change the web client, you need to redeploy the services and vice versa. These really do not scale well in the long run. Then, why not separate the client and the service from the get-go? In the end, when you write a RESTful web service, you already consider being used by external applications anyway, and adding cross-origin support is really easy. So, how do I do it? It's very simple. You must add the following HTTP headers to your responses: access control allow origin, access control allow methods, and access control allow headers. You can customize the values of these headers to restrict access to specific methods, allow only certain headers, and let only specific servers to connect. And that's all there is to it. How do you do it using Express and specifically in the movie application? Well, in the REST server.js, you need to add a function that will write cross-origin headers. Functions that execute on all requests can be added to the application using the use function. This function receives a function with the request, response, and next parameter. The order of the use functions matter. Since you want to apply these functions before anything else, it has to be called just after the body parser function. You can do whatever you want with the response and the request, but it's important that when you are done, you invoke the next function. To add a header to the response, use response.header, and then the name of the header and its value. In my case, I will add response.header access control allow origin with dashes between the words and uppercase in the first letter of each. This is equal to asterisk. This means that all servers can access my service. The next one is access control allow methods, and then the HTTP methods I want, in my case get, put, post, and delete, separated by commas. Then access control allow headers, and then the headers I want is content type with a dash in the middle, and authorization. Then call the next function. This continues the execution of your application methods. And that's all. Now for a demo. I got a separate HTML file. This file uses an AJAX request to get the movie data. It is a very simple application. I open the file in a web browser and it asks me where to connect. By default, it connects to localhost 8888. By the way, you can use this HTML client to test your application too. If I try to connect the server without the cross-origin headers, the application will fail either at connect or when I try to do a post, update, or delete operation. But wait, isn't the server and the client running in the VM? Well, yes and no. The server is running on localhost, and the HTML file is open in the file system. You see, for the browser, those two things are separate servers. One is on the file system, the other is on the network, albeit it isn't the same machine. But for the browser, it might be as well a different machine and applies the security rules regardless. So if you want to test using the HTML client, you must add the cross-domain headers because otherwise the browser will prevent you from connecting because the client is open in the file system locally and the server is accessed using a network connection. You can use this client to connect to the server once it's deployed on the cloud. If you want to learn more about cross-origin policies and its headers, you can find it in the Mozilla Foundation documentation for developers. Also, you can take a look at the HTML client to learn a little about JavaScript on the client side. When you're ready to continue, go to the next video.